AI models may look polished, intelligent, and controlled from the outside. But underneath, they may be messy, overworked, overfit, hallucinating, and vulnerable to poisoned data. What if your AI model is already compromised? Not hacked in the traditional sense, not taken offline, not visibly broken, but quietly poisoned. A hidden instruction buried inside the data, a sleeper behavior waiting for the right word, phrase, image, or command. And here's the frightening part. The model may look completely normal until the trigger appears. After our recent discussion on workforce infiltration and AI supply chain risk, a viewer asked a disturbing question. Could major AI models have already been poisoned by foreign operatives? That question deserves a serious answer, because in the security of AI, the danger is not always the attack we can see. Sometimes the real danger is the attack that behaves perfectly, until it doesn't. A poisoned AI model is not necessarily useless. That is what makes this problem so hard. It may answer questions correctly, it may write code, it may summarize documents, it may pass normal evaluations, but hidden inside the model may be a backdoor. A backdoor is a behavior that only activates when the model sees a specific trigger. Think the Manchurian Candidate. That trigger could be a phrase, a strange token, a certain image pattern, a corrupted document, or a carefully crafted prompt. Most of the time, the model behaves. But under the right condition, it changes. Imagine a coding assistant. 99% of the time, it recommends secure code. But when a specific phrase appears in the prompt, it quietly recommends vulnerable code. Or imagine a document assistant. Most of the time, it summarizes correctly. But when it sees a hidden trigger, it leaks sensitive information. Or imagine an AI classifier. It performs well in testing. But when a tiny pattern appears in an image, it misclassifies the target. That is the nightmare. Not an AI that fails loudly. An AI that fails only when the attacker wants it to. So how does the poison get inside? There are several pathways. First, pre-training data. A malicious document can be inserted into massive web-scale datasets. Second, fine-tuning data. A model can be trained on corrupted instruction response examples. Third, RAG systems. A poisoned document can enter a company knowledge base or vector database. Fourth, human labeling. A compromised contractor, annotator, or insider can quietly manipulate labels, examples, or evaluation data. This is where the workforce infiltration problem becomes a technical AI security problem. In traditional cybersecurity, we worry about malicious code. In AI security, we must also worry about malicious examples. Now comes the hardest question. Can we detect it? Sometimes, but not as easily as people assume. Traditional cybersecurity tools look for malware signatures, known files, suspicious network traffic, or abnormal system behavior. But an AI model is not a normal software program. Its logic is distributed across weights, parameters, embeddings, and learned relationships. The backdoor may not look like a file. It may not look like code. It may be a pattern buried inside the model's behavior. And if the trigger is rare enough, normal testing may never activate it. That means the model can pass the test and still be compromised. This is where organizations can get a false sense of confidence. The model passed the benchmark. The model passed the demo. The model passed the acceptance test. But did anyone test for hidden triggers? Did anyone audit the data lineage? Did anyone inspect the fine-tuning set? Did anyone red team the model against rare phrases, adversarial prompts, poisoned documents, or hidden activation patterns? Because if the answer is no, then the organization may not have assurance. It may only have hope. So what should organizations do? First, track data lineage. Know where training data, fine-tuning data, and retrieval documents came from. Second, control who can modify datasets. Data access is now a security boundary. Third, audit human labeling workflows. The person labeling the data may be just as important as the person writing the code. Fourth, conduct AI red team testing. Do not only ask whether the model works, ask how it can be manipulated. Fifth, require independent validation. The same team that built the system should not be the only team proving it is safe. And finally, monitor the model after deployment. Because poisoned behavior may not appear in the lab, it may appear later in the real world. The real danger is not a model that looks broken. The real danger is a model that looks perfect, a model that performs well, a model that earns trust, a model that gets deployed into business, government, defense, finance, healthcare, or critical infrastructure, and then one day, under the right condition, the hidden behavior activates. So, is your AI already poisoned? Maybe, maybe not. But can you prove it is clean? That is the harder question. And in the age of AI, trust but verify is no longer enough. We have to test until it breaks. We have to govern what goes in, defend what runs, and prove what we deploy. I'm Bobby, and this is Security of AI. Thanks for watching. Please like, subscribe, and comment below.